that when the coaster is getting ready to come up the hill, it has a lot of kinetic energy, but it doesn't have very much potential energy. As it goes up the hill, it slows down because its kinetic energy is becoming potential energy. At this point, these are opposites. So you see here I have a lot of kinetic, not very much potential. Here I have a lot of potential, not very much kinetic. At this point, what's going to happen is you're going to turn some of that potential energy into kinetic energy, as you can see on these bar graphs. It begins to kind of even out as the coaster picks up speed. Now, the whole time, the amount of kinetic and potential energy it has, that's fluctuating back and forth. But the overall amount of energy is staying the same, except for what? If you notice, the wheels and the track are touching, the wheels are moving. So we have friction. So friction is going to be taking away some of this energy. And as a matter of fact, if this cart goes very fast, and when this ride is done, if you touch those wheels, it's going to feel very hot because you have a lot of friction going on as it moves across the track. So let's look right here. We have our formula, which says that mechanical energy, ME, is equivalent to KE plus PE. So mechanical energy is equal to 1/2 mass velocity squared, that's my formula for kinetic energy, plus mass times gravity times height. Or we could say weight times height, same thing. So mechanical energy is equal to PE plus KE. Now, don't have to count for friction unless I tell you otherwise. If I give you a problem or some kind of an equation to solve, don't worry about friction unless I tell you to do so. Just understand that generally, anytime you have kinetic energy, it's going to be there, it's going to be present in some way. So let's look at two examples. Here we have the first question, which states, during a certain time interval, a 20 Newton object free falls 10 meters. The object gains blank joules of kinetic energy during this interval. So how will we find the kinetic energy? Remember that it's 1/2 mass velocity squared. But here, I don't have to do that. I know that the kinetic energy that this is going to have is going to come from its potential energy. So if I find potential energy, I'm going to know how much kinetic energy it has. So 20 times 10 is 200. 200 joules. Again, these are SI units. I have newtons, I have meters. So I know this will be 200 joules minus whatever friction would be present. So again, you have the kinetic energy of all of this object is coming directly from its potential energy. It's just a simple energy transfer. The second question is a little more complex. The car has a mass of 2,000 kilograms and is traveling at a speed of 5 meters per second. It reaches the top of a hill that is 10 meters high. What is its total mechanical energy? So to solve this, I need to do a couple of different things. Let me just kind of clear the screen here so that I have a blank space to work. All right. So the first thing to note was its mass. And it kind of helps to draw a little picture. So I know that the height of this hill is 10 meters. I know the mass of the car was 2,000 kilograms. I know the velocity or the speed of the car that it was traveling. If I look back in the question, it says 5 meters per second. So that's in SI units, that's easy to work with. And let's see what else. I know its weight is going to have to be roughly equal to, I'll just change my equal sign here. Its weight is going to be about, I'm just going to multiply by 10, I'm going to say 20,000 newtons. Alright, so now I have my information, I'm ready to begin to solve. I know that mechanical energy is potential energy plus kinetic energy. I know that my potential energy is weight height. My height is 10 meters. My weight is 20,000 newtons. So my potential energy should be equal to 20,000 times 10, which is 200,000 joules. Okay? So I'm about halfway done with my solution here. Kinetic energy. Remember, for kinetic energy, you multiply together 4 different things. Kinetic energy is 1/2 mass velocity squared. So for us, that means it's going to be 0.5 times its mass, which is 2,000 kilograms. Always use kilograms. Times velocity, 5 meters per second. Times velocity, 5 meters per second. And when we do that, we put it all together, we're going to have, so you have the 5 times 5, that's going to be 25. So you're going to basically have 2,000 times 0.5 gives us 1,000. 1,000 times 25 gives us 25,000 joules. And so now to solve the equation, we simply have to say we need to add, so mechanical energy here is going to be 200,000 joules plus 25,000 joules, which gives us a total of 225,000 joules. Now this one was a little more complicated because we had to actually do a lot here. We had to, calculate potential energy, then calculate, kinetic energy and add them together, and that's how we got our answer. But there's many times that you're going to ask, you're going to be asked to convert one form to the other, and your problem's going to be halfway done before you even begin. So stay tuned for part 2. We're going to talk more about friction, and we're going to have further episodes all on the same subject, and we're also going to be exploring thermal energy and heat transfers in other energy episodes. Thank you.